Eratosthenes determined the distance from Alexandria to Syene to be 5,000 stadia. If one stadium is equivalent to 185 meters, calculate the distance in kilometers between these two cities. So the easiest way I think to do this is to firstly think about your ratios, so the stadium to meters. So we know that one stadium is equivalent to 185 meters, but we don't have one stadium, we have 5,000 like it tells us in the question. So what do we need to do to get from 1 to 5,000? Well, we obviously multiply by 5,000. So if we do that, 185 multiplied by 5,000 gives us 925,000 meters. Remembering that the answer wants us to be in kilometers, so we know we simply divide by 1,000 to get kilometers. So 925,000 meters is equivalent to 925 kilometers. Okay, in the next question, two students, Fred and Wilma, live at different locations in the Northern Hemisphere and conduct an experiment to determine the circumference of the Earth. They use shadow sticks to measure the angle of the sun above their horizon at their local noon on a certain day of the year. Fred measures the angle of the sun as 61 degrees above the horizon and Wilma as 43 degrees. And we know that Fred lives 1,945 kilometers further south than Wilma. Use the student's data to determine the circumference of the Earth, correct to two significant figures. So the first thing that we need to do is we need to work out the angular difference between Fred and Wilma, which we can simply do by measuring the difference between the 2 degrees. So 61 minus 43 degrees means that they live 18 degrees apart. Now it's telling us that we know that the difference between them, we know there is 1,945 kilometers between them. So what this is showing us is that if we think about the degrees and distance, we know that 18 degrees around the world is equivalent to 1,945 kilometers, but we don't have, we want to know the circumference all the way around the world. So all the way around the world will be 360 degrees. So we need to think about, well, what do we need to do to get from 360 to 18? We need to multiply by 20. So we need to do the same on this side. And if we multiply 1945 by 20, we get 38,900 kilometers. Remembering it says give it to two significant figures, so therefore it'll be a 3 for our first significant figure. This 8 is the second significant figure, but obviously the next number is 5 or higher, so the answer will be 39,000 kilometers. Remember to make sure you always check the units. Again, very similar question. Two students, Barney and Betty, live at different locations in the southern hemisphere. And again, we want to work out the differences between them. So we know that Barney at the top here is 47 degrees and 7 minutes. And Betty measures as 31 degrees and 43 minutes. So we need to work out the difference between them. So work out the difference between them. 31. So if we added on 15, that would give us to 46, 43. So that's 15 degrees. And get from 43 to 7, there's 17 degrees left to get to 47. And 7 more is going to be 24 minutes. Now, we can't very easily do the maths with it as minutes. So we're going to try and convert it into a decimal. So there are 60 minutes in 1 degree. So we're going to do 24 divided by 60 to give us the decimal. So that will be 0.4. So we can write this equivalent as 15.4 degrees. And that will make it a lot easier to do the maths with. So again, very similar to the last question, we can just carry on. So we've got the degrees and we've got the distance. So the degrees is 15.4 degrees and the distance 1,750. And of course we want 360 degrees. So 360 divided by 15.4 means that we are multiplying here by 23.377 approximately. You can continue on doing it more accurately. So we're going to obviously do the same on this side and multiply it by 1,750. And if we do that, we get 4 40,909. Now this time it's asked to give it to 3 significant figures, so therefore it'll be 40,009, 1, 2, 3. Next number is less than the 5, so zeros. So 40,900 kilometers. And finally, our final question: 2 aliens are at different locations, but with the same longitude on a planet. They measure the angle of a certain star above the horizon when it's at its highest point. One alien measures the altitude of the star as 41 degrees and 57 minutes, and the other measures its altitude as 48 degrees and 42 minutes. So the first thing we're going to do is we're going to work out the difference between 48 degrees and 42 minutes and 41 degrees and 57 minutes. So minusing those, we're going to get 6 degrees and 45 minutes. Now we want to convert this into our decimal. So we're going to do 45 minutes out of 60, which is 0.75. So therefore we know that the equivalent degrees difference between them is 6.75 degrees. So this one's slightly different. So we've got degrees and then we've got distance. So we know that 6.75 degrees is the difference between them, but we want to know the distance to work this out. But we also know that the 360 degrees all the way round is equivalent to the circumference of the planet, which is 27,627 kilometers. So this time we need to think about, well, what do we need to do to get from 360 to 6.75? So on our calculator we can work out that to do that we need to divide by approximately 53.3 recurring. So we need to do the same to this side, and doing the same to this side gives us 518 kilometers to the nearest kilometer.